If you are prepared for the worst, then you can achieve the best. Let's get started with this quote. My name is Aman Tripathi, and today we will discuss the next problem of the CODECHEF May 21 long challenge. So the problem is in front of you. You can read the problem. The page is open. The problem name is XOR equality. So for a given n, find the number of ways to choose an integer x from the range 0 to 2n minus 1 such that x XOR x plus 1 is equals to x plus 2 XOR x plus 3, where denotes the bitwise XOR operator. Okay. Since the number of valid x can be large, output it modulo 10 to the power 9 plus 7. So in the input we will get the t, the number of test cases, and the n, so we can get the range 2 to the power n minus 1. In the output we have to print the result by taking the modulus with the 10 to the power 9 plus 7. So the problem looks very easy, but what we have to do in this, see, this is the code for this. Don't look at this part first look from the line number 13. See, here we have taken the input. The program will execute from here as it is a function above that, so this, from this line the program will start executing, and the for loop is just for running the test cases, all the test cases. So we will get the input n in the loop, and then we have to calculate x to the power y modulus of p. So for calculating this, we can directly use this here, but we are using this function to calculate this. As we all know, see, the constraints are 10 to the power 5, 1 to 10 to the power 5, so values can be large, very large. So for very large values, x to the power y modulus p calculation will take more time, and if you will write this here and try to run, then it will show TLE, time limit exceeded. So to resolve that problem, we have to use this function. This is known as modular exponentiation. Modular exponentiation calculates the value of x to the power y modulus of p with the time complexity of O log n. Means in the worst case, the time taken will be log y, in the worst case. So, and if you wanna know more about modular exponentiation, then you can comment it out. I will make a video on modular exponentiation if you want that. Otherwise, I think you can search that on Google also if you want to know more about modular exponentiation. Rest the program is very easy. See, only 5 lines of code is written to do this. Rest is a function to solve this statement. So I will run this code on the CODECHEF IDE. So this is the CODECHEF IDE. I have written this program here, copied the program here, and I will run this with the given custom inputs. See, the custom inputs are like this only, 2, 1 and 2. So after running with this custom input, it's executing. See, it is successfully executed, and the output is 1 and 2. Here also the output is 1 and 2. I will not submit this problem also, as you all know I've already solved these, so there is no use of submitting this again. See, you can see here I've already solved this problem. Oh shit, yeah, I have already solved this problem and submitted also, so I will not submit this. I hope you will understand this problem. You have understand it easily. There's nothing more to tell now. I think you should search of the modular exponentiation on the Google if you want to know about this function. It is just used to calculate this value, x to the power y modulus of p. Nothing extra is done in this program, so you can do this easily. So thank you friends, we'll see you again. Bye.